Now let's look at another feature from behavior graphs: local maximum, local minimum, and absolute maximum. So another feature we would like to focus on is the location and value of the maximum and minimum. Well, visually on a graph, we can see where the maximum and minimum are located. There are some mathematical ideas we need to be aware of. Okay. So first, there's two types of maximums: local and absolute. Let's look at a local. Definition of local: a function f of x has a local maximum value at x. So a is some position, that's where it's located the maximum. If, when I enter that value into my function, it is greater than x, well, what's x? For all x in some interval from c to d, where a is in that interval. So a is somewhere in here, and no matter what I try to enter besides a, all the other values are not bigger than that one. That's just a. Note that the interval CD is made as what? Well, um, I had to have it over here, as narrow as needed around the value a. So we want to make this interval, like people try to make it big, and go, no, actually you make it small. And say, well, I can make it bigger and it's still true. That's great, but that's not what we're saying. Yeah, well, it's true. You're saying it's true. It's actually making a small. We can make the interval. How small do we need to make the interval so that this is true? So we don't care about the actual numbers. We know that all we care about is locating the maximum value. And a function has a local minimum at x equals a if the opposite is true. When I enter that value into this function, when I look at all the different other values in some interval c to d, where a is in that interval, we have that f of a is just smaller than anything else in that interval. And again, note that CD is made as narrow as possible around the value of a. So let's look at an example. Another thing that we have to be aware of is, note the local minimum and maximum cannot occur at an endpoint. So we're not going to look at endpoints. Only within the value has to be within some interval. So in other words, we're not going to consider if it's a C or a D. Only the A has to be somewhere in between. All right. So, and now I'm going to make a distinction. I think this is really important. Some books make really a big deal of it, others don't, ours does not. But where is the location of the local maximum? So you must understand that when you look at a horizontal and this XY coordinate system, the x-axis tells you where, while the y-axis tells you what you're looking for, or what is that you're getting. And if you look at graphs, like for example, the stock market, you see pictures of the stock market going up or down, or this axis tells you what the stock market value is, and this tells you is the when. But again, the when or the where, depending on this time or location, not your physical location. But again, this axis just tells you where, when it's happening, and this one tells you, when you read it, it tells you what it is that you're getting at that. So keep that in mind. So for example, where is the location of the local maximum? All right, so now we're looking for the location of local maximums. Well, again, I'm looking locally and I see that this is a high point. And again, a high point, if I just kind of create a little interval. How big? Again, doesn't matter. I'm not, all I care is to make sure I recognize that's a high point, and sure enough, in that little interval, that's a high point. So it's local. So where is that? So that means that I need to tell you the location, which is an x value. Let's say make this x and y. These are not marked right now, but oh yeah, they are. Not good though. So I'm gonna write, look, there's a local macro when x equals looks like 2. Anywhere else? No, what it's not a maximum? Right, but maximums cannot happen. Local maximums cannot happen, and endpoints. This is an endpoint. Again, the entire domain of this is to negative infinity. Sorry. negative infinity to 10. So that endpoint, and stopping at 10 exactly. So we're not going to include that. Okay, so that's the only location. And what are the values of the local maximum? So again, that just means that what's the y value? So the value of the local maximum is looks like 1, 2, 3, yep, 2. So the value is 2. So what indicates the value, the actual value of the maximum? Where it's happening? Where is the location of the local minimum? The exact opposite. Now local minimums, let's say I'm looking here. So here's a tiny little interval. And in a tiny little interval, it looks like when I go down, I finally reach a minimum, a small value within that interval. And that's happening at 4, looks like x equals 4. So at x equals 4, there's a minimum, but that's not the only minimum. So I'm going to use the notation where it's the x value such that one that I found is at 4. And where's another one? Again, if I create a little interval around that, I can see that right here is also a minimum locally, and that's happening at 0. So notice that there's other y values smaller than it, but I'm saying locally within this little interval, that is the smallest value within that little interval. Same thing. In that little interval, that's the lowest value. And that is where, and what are the values? So now here is the value that makes it small for that little local place. And here for this one, the y value is 0. And here the y value in this local minimum is 1, 2, -2. So -2 is the actual value. Now look at another thing, points. What points are the local minimum? So now notice, I was trying to make distinction between where and what. Your book doesn't quite do this. And your book sometimes just goes into, hey, just give me the point, the location. So in that case, I'm going to give you just an ordered pair. What points are the local minimums? Well, local minimums occur at 2 different places, and the location is 0, 0. And that's 1, and the other one's right here, which is at 4, -2. So 4, -2 is another one. So these are the points where the local minimum is located. But at that point, I'm giving you the where and the what, the where and the what, the whole thing together. All right. Let's look at now definition of absolute. The function f of x has an absolute maximum at x equals a if the following is true. F of a is greater than f of x in the, now here's the difference. This is not an interval. It is the domain of the function. I mean, this is the absolute. In the entire domain, this is the biggest thing, biggest y value. The function f of x has an absolute minimum at x equals a if the opposite is true. When you enter this value into f of a, the y value, represented here, is the smallest thing in the entire domain of f of x. So that means any x you put in here is going to be bigger than that value. Sorry, any x you put into the function, it will produce another y value that's bigger than this one. So notice the absolute max and min can occur at endpoints. So that's not a problem. For absolute max and minimum, you can have it at the endpoints. So using graphic example, what are the absolute maximums or minimums? If so, list them. Well, let's look at this. You'll notice that this, which was a local, also happens to be an absolute. So can a local maximum minimum be also an absolute? Yes. Yes, this is just like an added descriptor. Okay, so don't think of them as, well, two different things. It's just that this is now, besides being local, it also happens to be absolute minimum. So I'm going to write the words here. There is an absolute minimum of y equals -2 at x equals 4. Okay, so the actual value is -2, but it's happening at x equals 4. Okay, is there an absolute maximum. Now we realize that, yeah, look, maximums can occur at an endpoint. Is this an absolute? No, because there's other values bigger than it. What about this one? How come we didn't use this one as a local? Again, can now have this one as a local because this point is equal to these. And we're not looking for equality. We're looking for the biggest thing within an interval. And within this interval, this is not the biggest. So in fact, it's equal to the rest of these other ones. So that's not good. But this one is absolutely the biggest y value. It's 6. And there's every other value here is smaller than it. So 6 is the absolute maximum. So there is an absolute maximum of y equals 6 at, and then where is it happening? At 10, x equals 10. So that's not a problem because this is about the domain. Over the entire domain, is there some y value that is the biggest thing, or is there some y value that is the smallest thing? One last example. Are there any absolute maximum minimums on this graph? Local max and local mins. So when I look at this, okay, let's look at the local stuff. Again, around this little interval, I'm going to assume that this is a solid point, closed. Looks like there is a local of 0.37 negative meters at x equals negative 2.5. Okay. Anywhere else? Well, right here too. There is a local minimum of negative 2.6 at now read it x equals 1.6. Fantastic. Okay. Then here, look right around this little interval, there is an local maximum. So there is a local max of what is local max? 0.8 at x equals so 1, 2, 3, 4. Yep. So it looks like at 1, negative 1 at x equals 1. Okay. And that is again local. Locally, this is a low maximum. Locally, this is a minimum. Locally, this is a minimum. Are there any, for example, absolute maximums? And the answer is no. Because now you're saying, wait a minute, what about this point? But this is open. Notice, it's got to be over the domain. What is the domain of this thing? The domain is, I'm assuming this is a solid point. So it starts at, looks like negative 3 and ends up at 5. So 5 is actually not part of the domain. So while 5 is big, it's not the biggest thing. And then there's what's below it. Well, I don't know. I can't get to it. It's just this is infinite many values, chapter 4, 5. So this has no absolute. I can't, if you look at definition of absolute, I can't, no matter what I try to put here, there's something, I'm going to find an x that's bigger than it, or could produce something bigger. So I can't get to that location because the 5 is not being included. So there is no absolute maximum. But we know there's an absolute min because if there's a local min, most likely there'll be an absolute min. So that happens right here. So this num I won't write it down, but this also right here happens to be the absolute. So this one is the local minimum, but it's also the absolute minimum as well.